Hello, my name is Osman, and I welcome you to the first section, let me say the first section that has to do with practical activity of our introduction to Matlab training by solid base um, engineering, simulation and design. Okay, in a quick word, today we'll be covering introduction to Matlab and basic commands. And we are expected to understand the role of Matlab in engineering application, navigate the Matlab environment for efficient problem solving, perform engineering calculations using basic arithmetic operation, introduce engineering specific variables and data types in Matlab. So moving on, we'll look at the application of Matlab in engineering. Um, Number one is numerical computation. So Matlab is extensively used for numerical computation, and this is evident in um, mathematical um, analysis. So um, Matlab provides a convenient environment for performing complex mathematical calculation, and engineers can easily manipulate matrix, those higher order matrix, and even some differential equation, solve linear algebraic equation, and perform various numerical simulations. So just a typical example is for those who are familiar with numerical analysis, where you have to do with iterations. Okay, you get to understand that when it get to some level of iterations, the calculation becomes cumbersome. So with MATLAB, it gives you that conveniency to carry out number of or higher number of iterations when it comes to analyzing to get to it, like just like when you're carrying out iteration using um, Newton-Raphson method, where you have where you are trying to find the root of an equation. So you find out that when you get to some a type of iteration you want to perform, the calculation becomes cumbersome when you're using the manual calculation method. But when you come to use MATLAB, you can get your several iterations within a couple of minutes. Okay, then we'll go to data analysis and visualization. Engineers use MATLAB for data analysis and visualization. It allows for efficient processing and visualization of large data set. Okay, making it valuable for tasks such as signal processing, image processing, and statistical analysis. We will not go into details about data analysis and visualization in this training, but it's good for you to know that if it comes to a project where you have to do data analysis and visualization, MATLAB is the best software to do those tasks. Then move on to algorithm development. MATLAB is extensively used for designing, analyzing, implementing, and carrying out experiment on an algorithm you develop. So if you want to develop and test algorithm, MATLAB has the convenient environment for you. Engineers can prototype and implement algorithm in a high level language, making it easier to translate ideas into code. And this is particularly useful for designing and refining algorithm before implementing them in other programming language or hardware. The, Next, we have control system. Okay, so MATLAB provides a specialized toolbox for control system design and analysis, and engineers can model, analyze, and simulate control system, making it a valuable tool for tasks like designing controllers for industrial process or analyzing the stability of feedback systems. Signal processing. In the same way, MATLAB is extensively used in signal processing and application or signal processing application. Engineers can perform tasks such as featuring Fourier series, Fourier transform, or let's just say Fourier analysis and spectral analysis. So making it an essential tool in areas like telecommunication, audio processing, and image processing. Machine learning and deep learning. Matlab is your best tool when it comes to machine learning and deep learning. Matlab provides tools for machine learning and deep learning, allowing engineers to develop and implement predictive models, okay, classification algorithm, and neural neural networks for a wide range of application. Uh, for guys who are into machine learning and deep learning like me, you come to understand that there are times where you want to implement this deep learning and machine learning in let me say in a system which you've designed. Possibly you're trying to carry out a predictive maintenance model and you want to test it on a plant. You can easily model your plant using the Matlab packages like Simulink, and then get your data from there and implement your deep learning at the same time while running your plant, and you get a model value for future research purpose. Okay, so MATLAB provides you a convenient environment where you can implement your machine learning or deep learning for whatever project you're working on. Then we move to communication system design. Okay, so MATLAB is utilized in the design and analysis of communication system, and engineers can model and simulate various communication protocols, analyze channel characteristics, and design error correction codes. And last but not least, we have the application deployment. Okay, most people think that it's only the computer guys that have to be designing application, but as engineering students or prospective engineers, you need to equally think that you have to be able to design applications, especially for your um, models which you would like to deploy to various platforms. MATLABs allow engineers to deploy the application, design and deploy the application and algorithm to different platforms. And this can be done through standalone application or web application, or integrate with other programming languages. Oh, so that's that for the applications of MATLAB in various engineering fields. Okay, so now we quickly look at the interface of MATLAB. So what you can see before you now is the MATLAB interface. And we'll quickly get to the basics of some of the interface so that we'll get ourselves familiar with it, and so that we'll be able to effectively navigate the environment once we want to start implementing our codes. So first we have to look at the command window. This is where your MATLAB commands are entered and in the line command. So now let's look at the command window in detail. The command window is where you can type and execute your MATLAB commands interactively. It is the main interface for entering and running MATLAB code. And the usage, you can type commands directly into the command window and see the result immediately. It is also used for displaying error messages, warnings, and other information generated during the execution of MATLAB code. So just a quick one, we are going to just carry out a simple example where we declare these variables and plot and get our result. So if for us to carry out this, we'll be switching to the MATLAB software. Okay, so now we want to carry out a simple example to see how our command window works. Okay, so I'll display my x to be equal to values from 1 to 5. Okay, then my y should be equal to x squared. Then I'll plot an x and y variable and see the result. Okay, so so this is it. So immediately I hit my plot command, I immediately get my result on a graph. Okay, so this is how I can use my command window to type in my commands and get my result immediately. Or I can do something like adding the x and y variable, that is x plus y, and I get a lot of result. So once the command window is highly interactive, it gives you a result immediately. So we'll go to the next window. Go to the next window, which is the ribbon. Okay, so this is the ribbon. This is what we call the ribbon, right? So it's on the top here. All this is what we call the ribbon, the blue line here, the blue area. And what is a ribbon? The ribbon is a graphical tool located at the top of the Matlab window. It provides quick access to various tools, commands, and features categorized into tabs such as Home, Plot, App, Editor, Publish, etc. The usage: you can use the ribbon to access commonly used functions, switch between different tabs, and navigate through Matlab features and tools. Okay, so when we talk about ribbon, tabs, and tools, now let me give you a typical example of that. Going back to our Matlab software. Okay, so now in our Matlab software, this is what we call the ribbon, right? So now this home, in the ribbon, we have what we call tab. Okay, so the ribbon houses tabs, and this is home tab, plot tabs, and app tabs. And in every tab, we have our various tools or functions we want to carry out. So these are the tools you found in the home tab. In the plot tab, these are the tools you find in the plot tab. In the app tab, these are the tools you find in the app tab. Okay, so that is just what the ribbon entails. So we quickly move on to the next, which is the workspace windows. It's there you find variables currently in the memory. So you declare a variable, which we are going to look at what are variables, what are data type, and when you declare them, these variables, when you declare them, are being stored in the workspace. Back to, let's see what the purpose and usage is. So the workspace window displays a list of the variables currently in the Matlab workspace along with their values. It provides information about the data you have created or imported during your Matlab session. And the usage is that you can view, manage, and manipulate variables directly from the workspace window. It is used for debugging and understanding the current state of your workspace. Okay, so now this is an example which says a is equals to 10, and then b houses values 1, 2, 3. So we can just implement this on our Matlab. Set a is equal to 10 and b is equals to 2, 3, 4, 5. Yeah, so I've declared my variables. Now my variable a has been defined here as 10, and I can choose to say call 10. What is a? When I choose to call a is equals to, my variable a is equals to 10, and my variable b here is holding the values for me 2, 3, 4, 5. Now these ones we are saying here are the initial variable I declared during my previous example on Windows command. And you can see that we have x to be 1, 2, 3, 4, 5 values, and y to be equals to square of x. Okay, so I can manipulate my variables here. I can choose to change this variable from 10 to 9. Okay, so initially when I just type a here, my a is 10, but I can change my variable here because I can change it to 9. Okay, and then when I type a, you see it has changed to 9, but it will be difficult for me to come here and change anything. it will be difficult for me to change anything. So whenever I want to change a variable, I come here to change it in the value section here. So that is that for the workspace. It helps you to store your variables that you've been declared during your programming. Okay, so now we go to the current folder. The current folder shows where the current folder is where you saved your your document, or where you saved your sheet that you're working on. And this current, so where I've saved my current working directory is engineer underscore mat eng underscore mat. So all the files that has to do with MATLAB coding and what have you are being displayed here in that folder. So it's just as if okay, just like you have a movie folder, and you pick out of the movie folder, you have a lot of movies in it, and you choose to watch one of the movie, and then by the side you have all the movies that are in that folder. So that is just how this current folder works. Okay, so this is just an overview, but we have a lot of other things that are there in the interface. So as we continue with this our training, we're going to get familiar with some of those other tools and functions. So we'll quickly dive into engineering specific variables and data types. Okay, so now in the context of engineering, or in the field, or in any field, a variable is a symbolic name or label given to a value or a piece of information. Think of it like a container that holds different types of information or data. Variables allows you to store, manipulate, and reference values in program or system. Okay, so what does this mean? What does this mean? Now, when we talk about container, okay, variable is just like, okay, let me give you something. Now, let's look at in engineering term, in simple engineering term, just a typical example. Voltage can be a variable. Okay, current can be a variable. The mass of a particular object can be a variable. Okay, so now those are what we call variable. So they are like a container that houses, or that holds different types of information. Okay, they hold different types of information for your programming for your programming, or for whatever analysis you're doing with MATLAB. And but in engineering, there's how we have list there's types of variables in engineering, which I would like us to quickly look at. And so, looking at the types of engineering variables, we have what we call the independent variable. We have what we call the independent variable. And so, for me to give you a typical example so that you understand what is called an independent variable, because it's very important you understand this basic concept as we make progress in our training, because we'll be utilizing some of these things subsequently. Now, in the study of in the study to investigate how the angle of a solar panel affect the amount of energy it generates. Now, the independent variable is the angle of the solar panel. I don't know, you just have to look at it at the independent variable, because what we are trying to do in this example is that you are trying to investigate how the angle, okay, of a solar panel affects the amount of energy is generated. So the independent variable here is the angle of the solar panel. Is the angle of the solar panel. Then the dependent variable, which is the second one, the dependent variable in the same solar panel study, the dependent variable is the amount of energy generated by the solar panel. So you have the angle as the independent variable, and the dependent variable is the amount of energy being generated. Then thirdly, we have the controlled variable. Controlled variable. So in an experiment testing the strength of different materials under tension, for controlled variable might include the temperature being applied, the humidity, and the types of testing equipment. So those can be the control variable in such scenario. Okay, Then we have the categorical variables, and in this one we call it that in a survey that it's about survey about preferred modes of transportation. Okay, the categorical variable is made up of with categories like car, bus, bicycle, and walking. So those are categorical data. Okay, so they are categorical variables in such scenario. Then we have what we call the continuous variable. Now, in the design of a bridge, okay, the continuous variable could be the length of the bridge or the amount of load it can bear. So in such scenario, the length of the bridge and the amount of load it can bear can be a continuous variable. And these are variables that are being utilized in the engineering field. Then we have the discrete variable. Now, in the manufacturing process, the discrete variable might be the number of units produced or the number of defects in a batch. The number of units produced or the number of defects in the batch. Then we have the nominal, and we equally have the ordinal. But for the purpose of this training, we'll not be looking into the nominal or ordinal. But last but not least, we have the time dependent variable. And so in a case study is in a study of temperature change throughout the day, the time dependent variable variable is a temperature which varies over different times like morning, afternoon, and night. So these are what we call the time dependent variable, and we will come to see how these are being used in when carrying out your analysis in Matlab. Okay, so that is that what for engineering variables. Now let's quickly look at data types. Now consider data types in Matlab to be a diverse container that houses various forms of information. It's similar to having different boxes for numbers, words, and other things, and other things, just in a simple term. So we'll dissect this just in a bit. So let me give you a more clearer explanation to what data types are. Okay, so you just imagine you have a container, you have a box, and this box contains there's a box for biscuits, there's box for gum, there's a box for different types of things. So you don't mix it, the box that is meant for biscuit, you don't bring gum into it. You don't bring gums into those because it will not fit in. So that's what we mean by data types, okay, in engineering. So data types are containers that houses various forms of information. So we'll look at a more detailed example moving forward. So we have numbers, or integers, or whole numbers, and data type. And so consider a box that can only contain a whole integer. Okay, a whole integer. We know what an integer is. 1, 2, 3, 4, like that, etc. So if you enter the number 2 into this field, Matlab recognizes it as a whole number. Okay, so in the same way, when you have integer of 8, you will have something like int 8 is like a tiny box that can hold a whole number and a whole numbers, and it's a special box because it only has 8 spaces inside. Okay, and imagine it's a box designed to store numbers ranging from minus 128 to 127. That's the unique feature about the whole number or integer data type. Okay, so engineers often deal with precise numerical values, and Matlab provides integer types like int 8, int 16, int 32, and int64, allowing them to work with specific data for precision requirement. Now, just as the example you have here, variable is being declared as int8. So we have integer. We are trying to declare an integer space, an integer that has 8 space for the number 2. We want to store our 2. We want to declare a 2 variable in it. So, and this is how the syntax will look like in Matlab. Then we have the float or decimal number. So consider another box that can carry integers with decimal points such as 10.6, okay, 10.6 and 11.2, 13.3, 150.5678, like that. So this decimal number, this float data type is different from the integer data type, okay, and these are what we mean by different boxes containing specific content. Or we have the int content, and we have another box dedicated for float. And so we can declare a float data type using this syntax. A variable 2 is equal to 10.6, which is a float, or we call it double data type. Then we have the logic true or false, and there is a separate area for true or false values. If anything is true, it is placed in the box, in this box, otherwise it is not. Okay, so when you come to a scenario like this, you engineers frequently encounter logical decision making in algorithms and control system. So Matlab logical data type is essential for representing true or false condition and facilitate efficient decision structure. And this is a syntax of declaring a logical true or false statement in Matlab. Then we have the text and words. We'll call it single character data type, and consider a box in the same way that can only hold one word at a time. So the box can only hold one word at a time, such as Matlab. So the whole box can only contain Matlab. So it is a function as a data identification tag, okay? And we can declare this as a variable for Matlab, and they are called character data type. These are what we call character, text, and words data type. Character data type is mostly common. Then we have numerous words. Now, when you have more than one word, in our conventional English language, we call it sentence. So, but in Matlab, we call it string. We call it string. So another box can store a string of words such as E and Michael, and this is an excellent. This is excellent for lighter statement or phrases in your coding. So we can declare it this way. You have your square bracket, your first word, then a comma, a second word, and this is how the syntax for the strings look like. Then we have mixed, we have cell or array, okay, and in this type of data type, there's a magical box that can hold many sort of stuffs at the same time. So it's shaped like a box with sections for various goods, making it extensively versatile. Okay, so this is how we declare a cell array data type. And we have the time and date data type. Finally, there is a separate area for dates and hours, and this box is ideal for remembering when something happened. Okay, so this is a date and the format for declaring a date and time data type. So in summary, this is how we'll implement the data types in Matlab and subsequently get our display variables like this. So we're going to carry out these tasks and see how we can obtain our result. So in summary, we'll get to see how we can generate these variables that will be currently in their workspace, which is one of the tasks we are expected to do after the end of the section. So thank you very much, and I look forward to giving you the tasks that we will do for um, to show if we're actually following up with the training and if we're actually getting the concept and the idea of the declaring variables and how to utilize data type in Matlab.